In this video, I'm going to be talking about some basics of probability. So let's take the situation where we're flipping a coin. We're going to flip this coin one time, okay? And obviously, the coin is either going to come up heads or it's going to come up tails. Okay, and we all know that the probability of flipping a coin and it landing on heads is 1 out of 2, okay, or 0.5. But let's just see what happens here. So we flip a coin and it lands on tails. So it's not heads, it lands on tails. So right now we have a 0 out of 1% of the time it lands on heads. Okay, so say we flip a coin a second time and it lands on tails again. So 0 out of 2 times it's landed on heads. So again, 0% of the time. And we flip a coin a third time, and finally it lands on heads. So now we have a 1 out of 3 probability, or I should say percent, that it's landed on heads. Okay? Now, as we go, let's just actually plot this, right? So we have, let's go, this is 0.5 up to 1. And on the first flip, okay, it was a 0. On the second flip, it was a 0. On the third flip, it landed on heads, and it got up to 0.333. So now we're here. Okay, so now we flip it a fourth time, and it lands on heads again. So 2 out of 4, that's 50%. Okay, so now fourth flip, we're up to 50%. Fifth flip, it lands on heads again. So now we have 3 out of 5, and we're up to now 60%. So now we're up here. Okay, now, as we go, let's say we flip it 10 times, and out of 10 times, it's landed on heads now 8 out of 10 times. So we're all the way up to 80%. So we went on a streak where it landed on heads each time. Okay, so now 10 times, we're all the way up here. Now, what do we think is going to happen as we flip this coin more and more times? Well, here's 0.5. We know 0.5 is the probability. What happens is we flip it more and more. Well, this probability is going to kind of zigzag our way until it starts to eventually approach 0.5. So as we go along, maybe we flip the coin 50 times and, we are still at, say, 27 out of 50. So we're still above 50%. We flip the coin 100 times, maybe we end up at, 51 out of 100. So we're at 51%. And we flip a coin 1,000 times, and maybe we're at 511 times out of 1,000. Okay, so still really close to 50%. But in the short term, what happens, this short-term probability is very unpredictable. But the long term, it becomes very predictable. And that is what we call the law of large numbers. So as there are more and more occurrences, this experimental probability approaches, let me just scroll here, okay? This experimental probability, what I mean by that is this probability that I'm finding we're actually executing this experiment and calculating the probability based on the results of our experiment. But over the long term, the experimental probability is going to approach the theoretical probability, which we can calculate analytically. So now let us calculate, or I should say, not calculate, let us interpret this. Let us interpret this probability. So we're going to say, if we flip a coin many, many times, the probability of it landing on heads is 0.5 or 50%. Okay, so types of probability. Okay, I've already gone into experimental probability and theoretical probability. Now, our notation when we're dealing with probability, generally write capital P. This is a little too thick here. Capital P for probability, and then the event. So in this case, it's heads. And you would write your probability. Okay, now, complements. So two events are complements if they sum to 1. So say we know the probability of heads is 0.5. Well, what's the probability of getting tails? Well, we could just subtract the probability of getting heads, and we would get 0.5, which we already knew, obviously, going into it. Okay, another way of thinking about this, though, I guess I'll write the rule, right? The probability of getting tails, we'll call this A, right, is equal to 1 minus the probability of not A. Okay, and that's written as A, what looks like to the power of C. But that little c stands for complement. Okay, or, put in quotes here, not A. Okay, and then just a little note. Okay, this is true because the probability of A plus the probability of not A is equal to 1. Okay, let's look at another situation. Here we are flipping a coin 3 times. So, what could happen when we're flipping a coin 3 times? Well, let's just go through all the possibilities. We could get, let me just get rid of that. We could get heads, heads, heads. We could get, so this is 3 heads. This is how I kind of keep organized about this. We could get 2 heads, and this would be heads, heads, tails, or heads, tails, heads, or tails, heads, heads. We could get 1 head. That would be heads, tails, 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 heads, tails, 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 heads. Or we get no heads, which would be tails, tails, tails. Okay, so these are all the possibilities. This is called the sample space. Okay, gives us all of the possible outcomes. So from our sample space, we're going to make a probability model. So our probability model, let us I'm going to set it up as a table. I'm going to have the number of heads and then the probability. Okay, so just going to do this in reverse order as I set up my sample space. So the number of heads, we could have 0 heads when we flip a coin 3 times, and that probability is 1 of the outcomes has no heads. That's tails, 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 right up here. Out of 1, 2, 3, 4, 5, 6, 7, 8 possibilities. So our probability is 1 out of 8 that we would get no heads. We could get 1 head. If we count those up, we got 1, 2, 3 possible outcomes out of 8. We could get 2 heads, and that's 1, 2, 3. That's 3 outcomes out of 8. And then finally, we could get 3 heads, which is just 1 out of 8. So we have our probability model. Now, is our probability model valid? Well, there's 2 things that we need to check. First, do the probabilities, do they add up to 1 or do they sum to 1? Okay, and we could just check this. 1/8 plus 3/8 is 4/8 plus another 3/8 is 7/8 plus another 1/8 is 1. Yes. The second thing we have to check is, are the probabilities between 0 and 1? Okay, and they could be 0 and they could be 1. So this is the inclusive between. So are the probabilities between 0 and 1? 1/8, 3/8, 3/8, and 1/8 are all between 0 and 1. So that is true. So our probability model is valid. Okay. I am going to stop this video there. That covers most of the basics of probability. In the next video, I'm going to go a little bit beyond the basics into the general addition rule and independence.